Okay, well, hello, my students. Here we're going down the road close to Christmas. What do I want for Christmas? I don't know. Hey, how about some food? No, I get that anyways. But anyways, here we're going down. I had you try to do matrices, multiply matrices on your own. I thought, well, I'll make a little video, make sure everything's okay. So really, I told you before, when you're multiplying matrices, think of this. Whoop, whoop. Because that's what it is. Let's do it one more time. Whoop, whoop. So what you do is you take the first row of the first matrix, rotate it. So it's horizontal now. Rotate it and then multiply it to the first column of the second matrix. So let me do this. So you'd have 2 times 1 plus 3 times 1. So the 2 is multiplied to the 1. The 3 is multiplied to this one. That'd be row 1, column 1. So row 1, column 1 is right here. So 2 plus 3 is 5. Then you do row 1, column 2. So 2 to the 2, 3 to the 3. Let me move this over. Sorry about that. That'd be 4 plus 9 is 13. Row 1, column 2. Then 2 times 0 is 0. 3 times 1 is 3. 0 plus 3 is 3. I think we're getting the hang of it. So then 1 times 1, row 2, column 1. So 1 times 1 is 1. 0 times 1 is 0. 1 plus 0 is 1. Row 2, column 1. Doink, doink. 1 times 2, 0 times 3, so that would be 2. 1 times 0 is 0. 0 times 1 is 0. So really, there's not much to it. Someone just came up with this and they said, okay, that's how math works. Yeah, figure out a way. Now, that means there's a lot of matrices that cannot be multiplied together. So if you notice this one, row 1, then column 1, you'd have 5 to the 2, 2 to the 6, but oh no, there's nothing to multiply the 1 by. So we cannot multiply these together. So here's the little trick. Here's the little trick. Are you listening? It's the little trick. You'd put the dimensions of this one down, and it'd be a 2 by 3. Oh, wait a minute. I messed up, didn't I? Sorry. It's a 3 by 2. I can't read. So 1, 2, 3 rows. 2 columns. Now this one would be 1, 2, 3 rows, 1, 2, 3 columns. The only time you can multiply is when the inner two numbers are the same. Now notice, if I put this over here, you could multiply them because that would be a 3 by 3 times a 3 by 2. Same numbers, you can do it. So notice, doink, doink. So positioning of matrices does matter. Cannot multiply it if it's this times this, but I can multiply it if it's this times this. So the columns of the first one has to, it's stuck. Columns of the first one have to match the rows of the second one. So good test question after Christmas. Can you switch the order of matrices and always be able to multiply them? And the answer is no. Sometimes you can, sometimes you can't. So let's look at this one. We have 1 row, 3 columns. Here we have 3 rows, 2 columns. Well, look there. You can multiply them. So let's go ahead and multiply them here. In fact, turn off the TV and go ahead and try to multiply them right now. Then turn it back on and I'll do it. Well, good. Here, row 1, column 1. So it'd be 4 times 1 is 4, plus 6 times 0 is 0, plus 1 times 2 is 2. 4 plus 2, I do believe, is 6. Then row 1, column 2, 4 times 3 is 12. 6 times 1 is 6. And 1 times negative 1 is minus 1. So 18 minus 1 is 17. So notice we went from a 1 by 3, a 3 by 2, and now we just have a 1 by 2. Notice what this number and this are a 1 by 2. So when you multiply, the outside numbers actually give you what the new matrix should be. Now I know this is a short video, made it a short video because I should have figured this out a while ago. But hey, have a happy day.